If you have ever been curious about how your devices can read your mind and just predict what you are going to type, so that's what we are going to code today. Today, we are going to code the sentence autocompletion model using machine learning, specifically deep learning and LSTMs. Let's get into it. So, welcome to the tutorial part of this project. Now, what we are going to do is going to head to Google Colab and then just start coding our project from scratch. So now for this project, we are using the dataset called Holmes. It is based on Sherlock Holmes books and their conversations from the books. So this dataset might not be the best for this, but for the testing purposes, for the just tutorial purposes, we're going to use that. You can use your own database and follow similar kind of structures. It will be no stress, no issues, no need to worry. You can use your own datasets. Let's get into it. Okay. So now, as you can see, we have already gone into the Google Colab section and yeah, let's just start coding. Firstly, what we will do is import the necessary libraries. For the necessary libraries, what we are going to do is we needed some like libraries like NumPy, then TensorFlow, and maybe some layers, then optimizers, etc. etc. And there's one library called RE. That library is actually used in order to do some text modification in the TXT files. Okay, so I'll be using that for that. So yeah, let's get into it. Okay, firstly, what we will import is NumPy. Then we will import TensorFlow STF. Now, what we will do for padding the sequences, we will need pad sequences, and then we will need some layer types like LSTM, then bidirectional layers, and our normal dense layers. Okay, so now firstly let's do from TensorFlow dot keras dot preprocessing dot sequence. We will import add sequences. I hope I spelled it correctly. Then from TensorFlow dot keras dot layers, we will import embedding, then LSTM, then bidirectional, okay. I hope that does that, and also we will need the Tensor. Now from TensorFlow dot again keras dot now preprocessing, okay, dot text. So for text preprocessing, we will import the tokenizers in order to tokenize our sentences. Okay, so now we will import the general optimizer, that is Adam optimizer. You can use HJD, whatever you like. Okay, so from TensorFlow dot keras dot optimizers, we will import Adam. Now the sequential model. Okay, the TensorFlow dot keras dot model, that is models actually, then import sequential. I hope I also spelled that correctly. Nope, that's a T. Okay, so now last library, that is we are going to import RE for the text manipulation. Okay, TensorFlow, and that should do it. What I missed? Okay, there's nothing called sequences. That's sequences. Okay. Now, what we'll do is just import the files and then start processing the file content, text content. That I mean. Okay. So let's define our input file equals to, and if you go here and here, as you can see, the homes.txt, that's there. So the homes.txt will be there. Okay, let's do it in the string format, and now let's read it. Not read it, and let's read the file. So with open, we'll open the input file in the read mode. Okay, with the encoding UTF-8 equals to UTF-8 as file. Okay, so now data will be equal to file.read, and that should be saved. Okay, so if we just print the data till the first, let's say 100 characters, that should give us the first lines of the file, that is Project Gutenberg, e-text of Tom Swift and his submarine, whatever, that's the thing. Okay, now the data is so large that it will take so much time in order to do so. Now what we will do is we will just limit the data to a certain number of characters, let's say 5 lakh. So let's limit that. So data will be equal to data till 5 lakh. Yep, that should do it. That's a 500,000 characters, and that's so much. Okay, so now I have copied something in order to clean the text. So as you can see, the text contains characters like hashes, then backslashes, etc., etc., the new line characters, etc., etc. So we will just remove it using the RE. So for that, we are going to just take this function that I'll paste here. Okay, as you can see, it contains the Unicode for emojis, then symbols, pictographs, then chess symbols, etc., etc. With RE, what we can do is define those Unicodes and then remove those Unicodes from our input file, like the data. Okay, now that it's done, let's run it. Okay, now what we will do is, well, let's just define a pre-process pipeline. So def pre-process pipeline in order to pre-process our data. So the data, and what we will return the list. Okay, now sentences will be equal to, let's split the data according to the new line characters. Okay, so our data will be separated into the sentences using the split function that will take \n as a separator. So now let's iterate through it. So for I in range length of sentences, what we will do, we will be removing spaces, then empty sentences, dropping empty sentences, then tokenize it, and then reprocessing is done. Okay, lastly what we will do is will pre-process the tokenized sentences. Okay. So for I in range length of sentences, if sentences of I will be equal to, now this function will be called here. We will be removing all the special characters, etc., etc. Control V, and we will pass the sentences of I there. Okay, that's done. Now then let's remove the leading and trailing spaces. Okay, so what we will do is now sentences will be equal to s dot strip for, not here, for s in sentences. So for every sentence it will strip it and give it in a list. That should do it. So that's list comprehension done. So let's now drop the empty sentences. Okay, I hope I spelled it correctly again. Yep. So now sentences will be equal to s for s in sentences if the length of s is greater than 0. So now take a look at it. If the sentence length is greater than 0, that means the sentence is not empty. That's when we add it into the final sentences, like final data that we have. If the sentence has a 0 length, it will be just removed. Okay. So if length of s is greater than 0, that should do it. So now let's tokenize the sentences and let's define a list called tokenized. That will be an empty list that will contain the tokenized sentences. So for sentence in sentences, what we will do is tokenize it. So sentence equals to what tokenizing is, it will just convert our text data into numerical sequences. That's it, into numerical vectors. Generally we use libraries like NLP, etc., etc. But since we are using TensorFlow, their pre-processing tools will be more compatible with TensorFlow's like models. TensorFlow's pre-processing tools plus TensorFlow's model are best combination in my opinion. So yeah. So sentence, firstly we will do the sentence in lower format. So it will just normalize all the alphabets in a smaller format, like small alphabets that will be not capitalized anywhere. So now tokenized dot append sentence. Okay. Now let's return tokenized. Okay, now you may have noticed that I didn't do the actual vector conversion. Why? I'll just tell you later. Okay, so we have to use something called OOV token, that is out of vocabulary token. So that will be used for something like some words that are not into our tokenized as vocabulary. That's why we have to use OOV token. We'll set it right after this. Wait for me. Okay. So lastly, what we will do is tokenized sentences will be equal to the preprocess pipeline's output. We will pass it the data. And if we run this, that should do it. Yep. Okay. remove sentences, emojis. Okay, so that should be the, like, what do you call it, the parenthesis. Okay, now that should work. Okay. Now we will set up the OOV token, and then let's fit the tokenizer on the text. That's it. So now let's get tokenizer equal to tokenizer, and let's do OOV token, that's what I told you, equals to angular bracket OOV angular bracket. That's it. Okay, so now tokenizer dot fit on text will be like, there's a function called fit on text, and then let's pass it the tokenized sentences. Okay, now let's do total words equals to the length of tokenizer dot word index plus 1. What this code does, it setups a tokenizer, then fits that tokenizer on the text that we have in the tokenized sentences that is returned to us from this preprocessing pipeline. Then we will get the total word length using the word index on that tokenizer. Okay, that's it actually. So let's generate the input sequences using some for loops. That will be a very easy task to do so. So now generate input sequences. Okay, so now let's do empty input sequences for now. That will contain an empty list, of course. Now for every line in tokenized sentences, what we will do is do a token list equal to tokenizer dot text to sequence, and what we will pass the line, add the 0th index, and that should do it. Now in another for loop we will do I in the range from 1 till the length of token list. Now what we will do is just we will get the n-gram sequence. So let's get the n-gram sequence equals to token list colon, and let's do I plus 1. That should do it. And the input sequences will be appended with the current n-gram sequences. Okay. That should do it. Lastly, what we'll have to do is pad the sequences. So for example, one sentence is shorter and one sentence is longer. For example, in this sentence, those both sentences should be fit into our TensorFlow model. But generally that does not happen because of the variable length. So now if that sentence is this short, this will be padded and this short sentence will be converted into the long sentence. Or on the other hand, what we can do is trim down the longer sentence. That's just a loss of data for us, so we're not doing that. So okay. So now let's add sentences. Okay, so max add length, sequence length. So let's get the largest sentence and then just add the shorter sentences to that length. Okay, so input sequences, and we'll be doing colon -1. No, actually, this is where we get the max function. Okay, so max of length of x for x in input sequences. Okay, that should do it. And now we'll just convert it to the NumPy arrays. So input sequences will be equal to np.array add sequences. We will give it the input sequences. Okay, then the max length will be equal to max sequence length. Okay, and let's do the pre-padding, so we will add the padding at the first. Okay, so let's do padding equals to pre, and that should do it for this cell. Okay, that runs fine. Now we will create the labels and the y variables, etc. So let's do x comma y, capital X comma short y. Here we will use the last that I did up here. Instead of max, what I will do is colon -1, and we will do the input sequences of colon -1. Okay, so that will give us the labels and the features. Okay, so now again y will be converted into categorical. So we have to convert it into categorical because that was text, although it is now a numerical form. That original form was a text. That's all. Okay, let's do tf.keras.utils.to categorical. And that should pop up here. It doesn't. No worries. So let's labels. Labels are stored in y. Then num classes will be equal to total words that we defined up above. Okay, so if we run this, that runs. Okay, the comma is not there actually. Yep. Oh, it's not categorical, it's categorical. Okay, that should do it. And now the fun part, or just the easiest part. The processing and cleaning up the data is like more advanced than the actual model training. So just let's train the model.